All right, so today we're going to look at 6.2, law of cosine. With law of cosine, law of cosine is a little messier, a longer formula than the law of sine. So anytime you can use law of sine, you want to use that. So law of cosine is kind of for all of the other cases of triangles. So again, these are triangles that are not right triangles. I mean, you can do them for a right triangle, but it's kind of silly. So this is for all those others. So law of sines was if you had two angles, and then one side or two sides and one angle that was not in between. So this is going to be for those opposite things. So this is for when you have all three sides but no angles, or if you have kind of like if you have no pairs. So if you have don't both have both A's or both B's. So if you have two sides and the angle in between. So say you have side B and C and angle A. So this is those other cases. The law of cosines is a little messier. It's related to the Pythagorean theorem. So it's a squared. Actually, let's start with the one that's very much like the Pythagorean theorem. So Pythagorean theorem says c squared equals a squared plus b squared. But because of it not being a right triangle, we have to add on this extra little piece of minus 2ab cosine of the angle. So this angle has to match up. So really important right here that this angle and this side match each other. The other two can be in either order. It doesn't matter on the other two. Now we can do this in any of the letters. So we don't have to just have c squared over there. We could also have a squared. And then it's b squared plus c squared. And then this would match the two in the middle. So 2bc cosine of capital A. Or you could start with b squared over here, if that happens to be, oops, the piece that you have, minus 2ac, and then cosine of capital B. So depending on which angle you have, is going to help you determine which formula you want to use. Those two always need to match, matchy, matchy. All right, so the capital angle goes with who is over on the right-hand side. So remember, again, you only use this when you don't have a pair. So if you have an angle, then you have that. Now, you can also rearrange the formula and solve for the, like if you don't have any of the angles, you can rearrange this formula into different forms. So one kind of example of that is you might want to solve it for cosine of, say we just take that top one, cosine of capital C, and I move the pieces to the other side. So it'd be c squared minus the a squared minus the b squared, and then divided by the negative 2ab. So you can rearrange and solve for the angles that you're missing. All right, so let's go ahead and jump in with an example. So say I give you that capital A is 42 degrees. Little b, we'll say is 13. And we'll say little c is 15. Okay, and we'll do meters on these. So notice we don't have a pair, so we can't use law of sines. So that's when we would use this case. Now, because I have capital A, then I'm going to use the equation that solves for little a. You always solve for the lowercase so that you will have a pairing. So I'm going to go little a squared equals, and I want b squared plus c squared minus 2bc cosine of capital A. So let's plug in. So this is 13 squared, this is 15 squared, this is that 13, that 15, and this is the 42. Now this whole right-hand side can be placed into your calculator all at once. So we're gonna do 13 squared plus 15 squared minus 2 times 13 times 15 times cosine of the 42. I'll plug it in all at once. Now remember that this gives me a squared. So this is a squared. So what would I do? Let's keep a couple of decimals right now. And then I'm going to square root both sides to solve. So I'm going to square root to get a. So if I square root my answer, I get 10.2. So now I have little a. So coming back up here, I needed little a, but I also need capital B and I need capital C. So once I get little a, then I can use the pairing from law of sines, so we can then use what we had before. So we put that 10.2 right here. Then I can use law of sines because now I have a pair of a's to solve for the capital B and capital C. And we typically want to find the smallest. Yeah, the smallest, because then we know it's not the ambiguous. So we'll go with sine of capital B over 13 equals the sine of 42. That's the A over the 10.2. So these are my A's that I brought in here. The B's are going here and here. All right, and using what we had in the past. So we're going to do sine of capital B equals our 13 times sine of 42 over the 10.2. And then we do inverse sine. Okay, so 13 times okay, that gives me 0.85. Then I do inverse sine on that. Try to use the A and S key so that you're not losing any decimals as you go. Whoa. Okay. Lost it. So hold on. 58.6 or 58.5, sorry. 58.5. And then once I have two of those, then I can do the 180 minus to find the third. So remember the triangle sum. So 180 minus 42 minus the 58.5. And I get my C. And we get 79.5. All right, so you have all of your pieces. So that is using law of sines. So now when you use law of sines, you're also going to still use the law of cosines. Sorry, this is using law of cosines. You're still going to use your law of sines, and you're also still going to use the triangle sum theorem. So as you find the missing pieces, then you're going to fill in the gaps with the other parts. Let's do a little example. Let's find side. Yep, let's do that. So let's say I have A is 9, B is 16, and C is 21. So I have all of the sides, but I don't have the angles. Oops, sorry. Now with this, you can pick any one that you want to start with. I typically pick the smallest and kind of go that way. So since you can go, let's see. But actually, it doesn't matter. We can do the largest to the smallest. It doesn't matter. So let's go. Okay, so we're going to use the formula from up here. So we're going to use this formula now. I guess that's cosine of C, so we could start with that. Cosine of capital C is going to be C squared, so 21 squared, minus our A squared, minus our 16 squared, all over -2 times our A times our B, which is our 16. So we're going to plug all of that in, and then we can do the inverse cosine on that. Okay. So we get -0.36. We do inverse cosine on that. And we get 113, or 111, sorry. 111 degrees. All right, and then once I know that, then I could set up another one, or I can go to law of sines now. So it's up to you whether you want to keep doing this format or if you want to switch to law of sines, because at this point you can. So you could switch over, and you could, now that you have a pair of C's, then I could find sine of capital A over 9 equals sine of our 111 over our 21, depending on okay, so I've got 9 times sine of divided by 21. So I've got sine of A equaling 0.4. Do my inverse sine. And I get capital A equaling 23.6 degrees. And then once I have those, then I can do the 180 minus the 111 and minus the 23.6 to get B. So sorry, I got sloppy. Capital A was 23.6, capital C was 111, and then capital B we will find right here, 180 minus the 23.6, and we have 45